In the 1960s, working at the Chevrolet factory was a solid middle-class job in the United States, often offering better pay relative to average wages than similar jobs do today. Back then, these factory workers earned about $3 per hour, wages that were significantly above the national average. You are now watching the start of production at the Chevrolet factory in the 1960s, the stamping of steel body panels from raw sheet metal. In 1959, Chevrolet sold over 1.7 million cars, beating Ford by about 250,000 units and regaining market dominance. Before automation, workers were a key part of car manufacturing and took pride in each car they built. Thanks to strong unions, many General Motors workers were able to support a family and afford a home and a car on a single income. Today, we have created a global economy and culture that often requires both men and women to work full-time, and then act surprised when people no longer have enough time to raise families. This is how factory workers processed and inspected the glass for quality. Back then, there was far more variation between cars than today. Each Chevrolet was almost a unique build. As you can see, workers along the assembly line manually inspected each glass panel, marking it okay if it passed quality control. These Chevrolets were built from around 13,000 individual parts. Today's cars can contain well over 35,000 components, reflecting just how much more complex modern vehicle manufacturing has become. Chevrolets were produced at numerous General Motors factories across the United States, with major production hubs in states such as Michigan, Ohio, and Missouri. This widespread manufacturing network allowed GM to supply cars efficiently to markets across the country. It also helped reduce transportation distances and overall shipping costs, making large-scale national distribution much more effective. By the mid-1950s, the United States had become the world's largest automobile market, producing more than 7 million cars each year. The industry was dominated by the big three automakers, General Motors, Ford, and Chrysler, which together accounted for roughly 95% of all car sales in the country. This concentration gave them enormous influence over production, design, and pricing across the entire U.S. auto market. In the mid-1960s, a new Chevrolet Impala cost around $2,500 to $3,000. For the average American family, owning a new car like an Impala in the 1960s was generally less financially burdensome than buying a new car is today, and when measured as a share of income. At the same time, automation was gradually increasing on the factory floor. However, most of the work was still highly labor-intensive, carried out by skilled workers in areas such as stamping, welding, and painting, where human labor remained essential to production. Each car was assembled from parts made in factories across the United States and shipped to the main assembly line. Right now, you are watching the wheel assembly process, which was partly carried out using mechanical machines that were still largely operated by factory workers. The model year system meant that cars were redesigned or updated every year, requiring costly changes in tooling, production lines, and factory equipment, as well as creating constant demand for the newest style and features. General Motors and Ford had the scale and financial strength to manage these frequent changes, quickly adapting their factories to new designs. Smaller independent manufacturers, however, often could not keep up with the rising costs and rapid production cycles, one of the key reasons many of them gradually disappeared from the market. The 1961 Chevrolets featured all-new styling, lower, longer, and sleeker than the 1960 models, reflecting a shift toward a more modern and streamlined design. Even back then, women did work in U.S. car factories, but they made up only about 10% of the workforce. Today, that share has increased to around 25%, reflecting gradual changes in the industry and the broader labor market over time. In 1963, 1 out of every 10 cars sold in the United States was a Chevrolet, highlighting the brand's strong position in the American automotive market at the time. At this time, independent brands such as Studebaker, Packard, Hudson, and Nash were still in existence, they were rapidly losing ground in the American automotive market. The 1950s marked a pivotal decade for American manufacturing, driven by rapid growth and the technological advances that followed World War II. Inside the factory, hard-working Americans built Chevrolet after Chevrolet. In that era, workers across the country experienced firsthand the strength and scale of the American automotive industry. Manufacturing was a key driver of the U.S. economy, powering industrial growth and producing everything from cars and household appliances to electronics and heavy machinery that defined everyday American life. At this General Motors assembly plant in Norwood, Chevrolet Impalas and Corvairs were produced throughout the 1960s. In the 1960s, Chevrolet offered so many factory options that buyers could essentially build their own car, choosing everything from engine size to interior trim. Because of this, two Chevrolet cars coming off the same assembly line could look and perform completely differently. Collectors often regard the 1955 to 1960 Chevrolets as one of the most iconic and influential periods in American automotive history, a time when design, performance, and mass appeal came together in a unique way. It all began with the 1955 models, which set a new standard by combining bold styling, improved performance, and affordability in a way that few, if any, competitors could match at the time. At the time, the American factory workforce was made up largely of young white men, many of them in their late 20s and early 30s, reflecting the demographics and hiring patterns of the era. Today, that picture has changed significantly, with a more diverse workforce in terms of age, gender, and background, as the industry and society have evolved over time. This is how massive engines were lifted by overhead cranes, carefully moved into position, and installed into the chassis frame. Now, this worker mounts the wheels onto the chassis, securing them in place and preparing the vehicle to move down the line for the next stage, body assembly. Interior materials, such as seat cloth, vinyl upholstery, and carpeting, were dyed at the material stage long before they ever reached the car assembly plant. General Motors required strict color consistency across all suppliers, making it a significant challenge to ensure that seats, door panels, and carpets matched perfectly in every vehicle. While the 1960s were known for their brighter, more expressive styling, today's cars offer a much broader and more technologically advanced range of colors and finishes. Right now, you are watching the process still known today as the marriage. At this point, two major production streams came together: the drivetrain and underbody assembly, and the finished body shell produced on a separate line. Using heavy overhead cranes and precision alignment systems, workers guided the two sections together before bolting them permanently as a single unit. Now, on this assembly line, the wiring is installed, and the interior and exterior components of the car are assembled. This quality inspector checks the finished Chevrolet and then places a sticker on the windshield indicating that the car has passed inspection. After completion, the cars were parked next to the production hall and then transported by trucks to dealerships. Please let me know in the comments if you enjoy this perspective on classic American cars from the last century. As you can see right now on the yellow truck, these carriers could transport only 4 cars at a time, far fewer than modern transporters can handle today. For long-distance transport, long freight trains were, of course, used. By the mid-1950s, the assembly line had been highly refined, allowing for faster and more efficient production than ever before. Plants were increasingly regionalized, meaning Chevrolet vehicles were built in more than 10 different factories across the United States to reduce shipping distances and cut transportation costs. By 1955, Chevrolet cars were being produced in multiple General Motors plants across the country, from Michigan to California, supporting a truly nationwide distribution system. That year proved to be a turning point, with the introduction of the small block V8 engine, record-breaking sales, and a renewed image that positioned Chevrolet as a more stylish and performance-oriented brand. This is another American automotive facility, shown about 30 years later, the Michigan truck plant in Wayne, Michigan. By the 1990s, robotic welding had become a standard process in most major American automobile factories, significantly improving speed, precision, and consistency in car body construction. Inside this plant, vehicles such as the Ford F-Series and the Ford Bronco were assembled, before production later shifted more heavily toward SUVs like the Ford Expedition and Lincoln Navigator. The factory often operated 2 to 3 shifts per day to meet strong market demand, combining advanced robotic automation with traditional manual assembly work. This setup reflected Ford's broader strategy during the 1990s, which focused on maximizing factory output during a major production boom in trucks and SUVs. After the painting and body preparation stages, the vehicle shells were transferred onto the main assembly line for final construction. By 1994, the Bronco lineup had switched exclusively to V8 engines, as the previously used 4.9-liter inline-six engine was discontinued. The 1995 Bronco was mechanically solid and built for long life, especially its V8 engines, but it was less efficient and more maintenance-heavy compared to modern SUV. Right now, you are watching the engine being carefully lowered into the chassis frame, while the front bumper is being prepared for installation. This stage of production, known as the marriage, is still performed in a way very similar to the methods used in General Motors plants during the 1960s. At this point, you are observing the production of both the Ford Bronco and the Ford F-150 light truck at the Michigan truck plant in Wayne. Between 1987 and 1991, the fourth-generation Bronco was built here, with around 54,000 units produced in 1990 alone. During the same period, the eighth-generation Ford F-150 was also being manufactured at this facility. You can also notice that some production steps were done in a relatively flexible or improvised manner, including the application of exterior decals and finishing details. Right now, workers are installing components such as lights, connecting wiring systems, bolting parts together, and fitting the vehicle seats into place. After the vehicle is fully assembled, it moves on to the final stage of quality inspection, where every system is carefully checked to ensure it meets all required manufacturing standards before leaving the plant. At this point, the senior factory worker with gray hair carefully reviews and approves the final inspection, confirming that the finished vehicles are safe, functional, and properly built. Color choices also played a role in customer appeal. Red was especially popular for its rugged, sporty appearance, while white and blue remained common depending on trim level and production year. In 1995, Ford Bronco reached one of its highest production years of the 1990s, with approximately 37,600 units manufactured. The Bronco and the Ford F-150 were both built on the same assembly line, sharing much of the production process. The Ford Bronco was later discontinued in 1996 and remained out of production until its return in 2021 with the sixth generation, which continues today. You are now watching the bodywork stage from 1994, where vehicle frames are being welded and fully assembled before final finishing. Even decades ago, factory management already paid attention to the well-being of employees, and over the years, the standards for a healthy working environment have significantly increased. After welding, sealant was applied along the body panels to improve durability, followed by immersion in a tank for anti-corrosion treatment to protect the metal from rust. The completed body then moved into the paint shop, where even in the 1990s, much of the painting process was already automated. Robotic arms sprayed paint across the vehicle bodies, although the process produced noticeable overspray, making it less efficient compared to modern systems. For many owners, the Bronco from this era became known as one of the most dependable vehicles they ever owned, valued for its strong V8 engine and rugged construction. In 1994 alone, more than 33,000 Broncos were produced at this facility. At this stage, you are watching the production of the fifth-generation Bronco, which represented the final evolution of the classic design before its discontinuation. A thick adhesive is applied around the windshield frame, and two workers carefully position and install the glass into place. The model was ultimately discontinued in 1996 and replaced by the Ford Expedition in 1997 as consumer demand shifted toward larger family SUVs. According to Ford, the discontinuation of the Bronco was not connected to the well-known O.J. Simpson police chase, despite public speculation at the time. In reality, sales of the model had already been declining before that event, reflecting changing market trends in the SUV segment. The engine is assembled separately on a dedicated production line, using carryover powertrains such as the 4.9-liter inline-six, the 5.0-liter V8, and the more powerful 5.8-liter V8. Immediately after the engine is installed and mated to the chassis frame, the vehicle's cab and rear body are carefully lowered into place, bringing the main structure of the truck or SUV together in a single coordinated step. During this period, most employees wore basic safety equipment such as goggles, gloves, and protective overalls, gear that was recommended at the time but is considered mandatory in modern manufacturing environments. At the end of the production sequence, dyno testing was used as a final real-world simulation, ensuring that the vehicle's engine, drivetrain, and controls all performed correctly before it left the factory. Production methods in the 1990s at Ford Motor Company relied more on manual inspection and hands-on testing, while today's manufacturing systems are far more automated, precise, and data-driven. During the 1990s, Ford was part of the Big Three American automakers, alongside General Motors and Chrysler, dominating the domestic automotive market. The Ford F-150 remained one of the best-selling vehicles in the United States, frequently holding the #1 position in overall sales, a position it continues to maintain today. The goal of shaker testing is to check for any weaknesses in the vehicle's structure and assembly. Engineers listen and observe for unusual noises, loose components, squeaks, or vibrations that could indicate a problem. It also helps identify issues with suspension, interior fittings, and electrical connections before the car reaches customers. This is what a brand new 1960 Chevrolet Impala Sport sedan and Chevrolet Corvair would have looked like on the road when they first appeared, representing two very different approaches to American automotive design of the era. During Chevrolet's development work in the 1960s, vehicles were subjected to extremely rigorous testing in both hot and cold extremes to ensure reliability in all climates. Right now, you are looking at testing inside a specialized environmental chamber designed specifically to recreate those harsh temperature conditions in a controlled laboratory setting. Prototype vehicles went through a full climate testing program, where engineers could simulate both scorching desert heat and freezing winter conditions within the same facility. These tests were essential for evaluating how critical components, such as engines, transmissions, rubber seals, and interior materials, would perform under long-term thermal stress. Engineers carefully monitored every detail, from cold engine starts in sub-zero temperatures to how comfortable the cabin remained during simulated extreme heat. Beyond laboratory conditions, test vehicles were also driven for thousands of miles across a variety of environments, including rough rural roads, steep mountain routes, and high-speed proving grounds. Right now, you are watching a front-mounted winch system being tested for strength and durability under extreme load conditions. In some cases, these systems were so strong that they were capable of lifting the entire vehicle off the ground without failure. The Chevrolet El Camino is another example from Chevrolet's history. First introduced in 1959, with only about 22,000 units produced that year. Today, due to its limited production numbers and unique coupe pickup design, it has become a highly desirable collector's classic. Well-preserved examples of the El Camino can typically sell in the range of $10,000 to $19,000, depending on condition and originality. Right now, you are watching production of the rare Chevrolet Corvette ZR1, one of the most advanced performance cars of its time. In 1992, only 502 units of the ZR1 were built at the Bowling Green, Kentucky assembly plant. That same year, total Corvette production was around 20,000 vehicles. The ZR1 performance package added approximately $31,000 to the price, nearly doubling the cost of a standard Corvette. Nicknamed the King of the Hill, the ZR1 delivered genuine supercar-level performance at a price that was still relatively accessible compared to European rivals. At the time, Car and Driver famously described the ZR1 as a car that goes fast better than the Porsche 911 Turbo, but at a significantly lower cost. The General Motors Norwood assembly plant in Norwood, Ohio, was a major hub of American automobile production for much of the 20th century. Operating from 1923 until its closure in 1987, the plant played a significant role in shaping the U.S. auto industry. When it first opened, the facility employed around 600 workers and was capable of producing up to 200 cars per day, an impressive output for its time. By the early 1970s, the plant had reached its peak, employing nearly 9,000 workers and contributing to the production of more than 8 million vehicles over its lifetime. During the 1960s, the Norwood plant became especially well known for producing some of Chevrolet's most iconic models, including the Impala, Nova, and Camaro. A key part of this productivity came from the use of the assembly line system, a manufacturing method popularized by Henry Ford. Instead of building cars entirely by hand, vehicles moved along a conveyor while workers performed specialized, repetitive tasks, such as installing engines at specific stations. This approach dramatically increased efficiency and reduced costs, making cars more accessible to the general public. With proper maintenance and regular care, many of these vehicles could last between 150,000 and 200,000 miles, or even longer in some cases. This machine automatically measured dimensions with very high precision, accurate to 1/10,000th of an inch. It reduced human error and ensured consistent, reliable results in manufacturing. The Chevrolet Impala of the 1960s, one of the standout models produced at Norwood, was known for its durability and ease of repair. With proper care and maintenance, these cars could remain reliable for many years, contributing to their lasting reputation among classic car enthusiasts today. You are now watching the production of the 4.6-liter Turbofire V8 engine as it is being assembled on the line. At its peak, more than 9,000 employees worked at the Norwood assembly plant in Ohio. And this General Motors facility also produced models such as the Chevrolet Biscayne, Caprice, Camaro, Pontiac Firebird, and Buick Apollo. The assembly line relied on precise timing, close teamwork, and careful organization to keep everything running smoothly. This stage of production is known as the marriage, when the vehicle's body and chassis are brought together as one. It's called this because major components, such as the engine, transmission, drive shaft, axles, and fuel tank, are installed together in one coordinated step, rather than being added separately at different stages. For decades, General Motors was the largest automaker in the United States and remained the world's biggest for 77 years, until Toyota surpassed it in 2008. In earlier years, the main production line relied on far more workers, before advances in automation and robotics gradually reduced the need for manual labor. These Chevrolet vehicles were assembled from a wide range of parts, supplied by subcontractors, all brought together at the plant. The entire assembly process resembled a giant jigsaw puzzle, with each piece carefully fitted into place until a complete car emerged. Right now, you can see how factory workers, working in coordination, installed the front hood onto each vehicle. You can also notice that these American workers are dressed in jeans and shirts. After assembly and initial startup, the Chevrolets were driven through a large water spray test, much like those used in modern factories today. During this stage, the cars underwent waterproof testing, where heavy sprays hit the exterior while the interior remained completely dry. Once running, models like the Chevrolet Impala were dyno tested to check engine performance and ensure all driver controls functioned properly. Dealers then performed final quality checks, polishing the cars and even adding a fresh scent before delivery to customers. After their work on the line, assembly workers could take a break, while a 1960s American family drove away in a brand new, dependable Chevrolet. It's also interesting that television commercials played an important role in promoting newly released cars at the time. Right now, you can see how Chevrolet advertised its vehicles, using the image of a happy family with their dog. In the 1960s, both US and European car makers used assembly lines, but their approach differed. US companies like General Motors focused on mass production, large cars, and high output. European makers such as Volkswagen and Fiat built smaller, more efficient cars with lower production volumes and longer model lifespans. Their production was generally more flexible, with longer-lasting models and gradual improvements rather than constant redesigns. This is the British Browns Lane factory, where Jaguar Mark II vehicles were built during the 1960s, representing one of the most refined examples of British automotive engineering of the era. At the time, Jaguar cars were widely recognized for their elegant styling, luxurious interiors, and strong performance, making them highly desirable both in the UK and abroad. Right now, you are watching the production of the Jaguar Mark II sedan, a model that became one of the brand's most iconic vehicles. This car was produced from 1959 until 1967, with approximately 85,000 units manufactured during its production run. The process begins with aluminum cylinder head castings being carefully loaded onto a production track for machining and finishing. Next, the hemispherical combustion chambers are precisely machined one by one, forming a key part of the engine's performance design. One of the first machining steps involves shaping the camshaft guides, which are critical for accurate valve timing. To install hardened steel valve and tappet guides, the cylinder head is heated in an industrial oven, causing the metal to expand and allowing components to be fitted with precision. In another stage, drilling operations are completed in a single pass, ensuring all vertical holes are accurately aligned. After cooling, the valve guides and valve seats are finally machined to exact tolerances, ensuring optimal engine efficiency and durability. The cylinder head is then polished until its surface is smooth and reflective, indicating a high level of craftsmanship. Subsidy high-pressure water jets are used to thoroughly clean the component, while compressed air removes any remaining metal shavings or debris. The internal cooling channels are then sealed and pressure tested by filling them with air and submerging the part in water to detect any cracks or leaks. Finally, a thin precision skim is taken from the surface to ensure perfect flatness before assembly. The engine blocks, made from high-grade cast iron, are produced with the same level of precision using advanced machining equipment to maintain strict tolerances. Once inspected and approved, the cylinder head is matched with the engine block for final assembly. You are now watching gear hobbing, where the teeth of a blank gear gradually take shape as the cutting tool removes material with high precision. After machining, every gear is carefully measured, with each face and angle checked to within 0.02 of an inch to ensure absolute accuracy. The main bearings are then machined to extremely fine tolerances, with a single operator often supervising multiple machines at once. The big end journals of the crankshaft are also machined in a similar process, maintaining the same high level of precision throughout. Once all machining is complete, the crankshaft undergoes static balancing tests to ensure smooth operation at high speeds. If any imbalance is detected, small amounts of excess metal are removed from the crankshaft webs, after which the shaft is tested again until perfect balance is achieved. Both the big end and main bearings are then ground down to extremely fine tolerances using high-speed carborundum grinding wheels, ensuring a perfectly smooth and precise finish. Next, all oil flow holes on the big end journals are carefully countersunk by hand using precision files, allowing for proper lubrication and long-term engine reliability. At this stage, both handwork and machine processes are combined, with skilled operators working alongside precision equipment to achieve the required level of accuracy. This is followed by the final lapping and polishing of all bearing surfaces, creating an exceptionally smooth finish to reduce friction during engine operation. A specially prepared ink-based inspection solution is then applied to the crankshaft, which has been magnetized for testing purposes. This process reveals even the smallest surface cracks or imperfections, making them visible to the naked eye and ensuring that only flawless crankshafts proceed further in production. After inspection, the crankshaft balance is checked once again, this time using dynamic testing to simulate real operating conditions. If any imbalance is detected, additional small amounts of metal are carefully removed from the crankshaft webs until perfect balance is achieved. So once completed, the crankshaft undergoes a final critical inspection before being released to the engine assembly line. The main assembly track is supplied by several sub-assembly stations, where components are prepared in advance for final engine construction. At one of these stations, the crankshaft, flywheel, and clutch are assembled together into a matched unit. Each component is individually numbered, then disassembled and carefully reassembled on the main line to ensure that perfectly matched parts remain together throughout the process. Meanwhile, connecting rods and pistons are being prepared for installation. Connecting rods are sorted into precise weight categories, with tolerances controlled within a maximum difference of just 2 grams. Their dimensions are also checked with extreme accuracy, down to 0.02 of an inch. Finally, end balance measurements are taken, further grouping the connecting rods into matched sets of 6 for uniform engine performance. This process relies heavily on the skill and experience of the operator, as every component must fit correctly at normal room temperature with no adjustments required later. Meanwhile, on the main assembly line, engine construction is progressing steadily. The crankshaft is carefully installed into the engine block and positioned with extreme precision to ensure perfect alignment within the main bearings. Next, the pistons are inserted one by one into their respective cylinders, with great care taken to avoid damage and ensure smooth movement. The connecting rods are then attached to the pistons and securely fastened to the crankshaft, forming a complete moving assembly inside the engine. Finally, the flywheel is fitted onto the end of the crankshaft and precisely aligned to ensure smooth rotation and proper engine balance. The clutch assembly is bolted into position, completing this major stage of engine construction. Before the cylinder head is fitted, all exhaust and inlet valves are carefully lapped into the valve seats they will permanently occupy, ensuring a perfect seal for efficient engine operation. With the cylinder head still removed, tappet clearances are measured and precisely adjusted to meet exact specifications. Once all settings are correct, the cylinder head is carefully fitted onto the engine block, completing the core structure of the engine and preparing it for gearbox installation. Each gearbox is assembled separately with equal precision and then tested inside a specially designed soundproof booth where technicians listen carefully for any unusual noises during simulated acceleration and braking cycles. After successfully passing these acoustic and mechanical tests, the gearbox is bolted directly to the engine as a complete unit. Throughout all of these stages, the guiding principle is strict quality control, with approximately 1 inspector assigned for every 9 production workers. The engine is then joined with the sump and filled with the correct grade of oil. However, this alone is not sufficient. Every engine must undergo a comprehensive bench test before it is approved for final use. First, the engine is run at a constant speed of around 1,500 revolutions per minute for approximately 3 hours to ensure stability and proper running in. It is then tested at a range of different speeds and loads, reaching up to a maximum of 3,500 revolutions per minute to simulate real operating conditions. After testing, the oil is drained, the sump is cleaned and reassembled, and the engine unit is prepared for final assembly on the main production line. You are now following the main assembly line, where the front axle and suspension system are first constructed as a complete sub-assembly unit. Next, both the front and rear axles, including disc brake systems, are installed onto a special supporting trestle for precise alignment. This is followed by the installation of the engine and gearbox as a single combined unit. Once assembled, the complete drivetrain is thoroughly inspected to ensure all components are correctly fitted and functioning as intended. Finally, the transmission shaft is connected, completing the drivetrain system. At this stage, it becomes clear that an incredible number of manufacturing and assembly tasks were performed entirely by hand, relying heavily on skilled labor and careful inspection at every step. Meanwhile, work continues in the paint shop, where the vehicle body is prepared and finished through a highly controlled and multi-stage process. If required, a special mechanism for seat reclining can also be installed, allowing the seat to be adjusted smoothly and securely locked in any chosen position for driver comfort. At this stage, a final detailed inspection of both the exterior and interior is carried out, ensuring every detail meets quality standards. Any minor imperfections or necessary adjustments are carefully corrected before the vehicle is approved for completion. The Jaguar Mark II itself is considered one of the most important and influential models in Jaguar's history, representing a perfect balance of performance, luxury, and classic British design. Now, this beautiful Jaguar Mark II is leaving the production facility and will experience daylight for the very first time, marking the moment it becomes a fully finished road car. At the time, customers could choose between several engine options, including a 2.4-liter, 3.4-liter, or 3.8-liter six-cylinder engine, depending on performance needs and budget. The most powerful version of the range produced up to 220 horsepower, making it the top performance option available in the lineup. These higher capacity models, especially those with the 3.8-liter engine, were the most commonly produced, with a total output of around 30,000 units. After assembly and initial testing, each vehicle was taken for an additional road test on public roads, driven by a different tester who evaluated real-world performance, handling, and reliability. Only after the tester was fully satisfied was the vehicle approved and returned to the factory. Once back at the plant, the interior was thoroughly vacuumed and carefully cleaned, ensuring a fresh and presentable finish. The entire exterior body was then hand-polished until it achieved a deep, glossy shine. A final critical inspection of the bodywork was carried out, and any necessary corrections or refinements were made before approval. At this stage, the car was considered ready for delivery and could be sent to its new owner within just a few days. This factory also produced the legendary Jaguar E-Type between 1961 and 1975, one of the most iconic British sports cars ever made. During that period, a total of approximately 72,000 E-Type vehicles were manufactured, earning worldwide recognition for their design and performance. The Jaguar factory eventually closed in 2005, marking the end of an important chapter in British automotive history. Today, the brand continues under new ownership and is undergoing a transition as it seeks to redefine its identity in the modern automotive industry.